In this video, we're going to talk about the last type of transformation, which is reflections. So far, we've talked about vertical and horizontal translations. We've talked about scaling our functions with a vertical scale, stretch, or compression. And now, like I said, we're going to talk about reflections briefly. So let's do a couple of examples first. As we've been doing, I'm going to start off with our function, or our parent function y equals x squared. Let me go ahead and get that graphed on here. And here's our parent function. Oops, that last point's not in a very good spot, is it? There we go. So here's our parent function. And we're now going to transform this function from f of x to g of x by taking all of our values, or all of our y values, and making them negative. Now, you might not be able to tell very easily that we're doing that to the y values, but it's because that negative sign is outside the squaring part of this function. If I had written negative x squared in parentheses, then we'd be doing slightly different than what we're going to be doing in this example. So let's go ahead and graph this function and see what it's going to look like. If I plug in 0 for x, of course I get out 0 for y. If I plug in a positive 1 for x, I get 1 squared, and I have to make that negative. So a positive 1 for x means I have a negative 1 for y. It'll be down here. If I plug in a positive 2 for x, 2 squared is 4. Make that negative, I get a negative 4 for y. And you can probably guess what's going to happen on the other side of the equation. If I plug in a negative 1 for x, negative 1 squared is positive 1, then I have to make that negative. So that becomes negative 1 for y. And then same with negative 2. Negative 2 squared is positive 4. But then if I make that negative, got a negative 4 there for y. If that point on the plot, there we go. So if I graph this function, here's what it looks like. And you can probably tell that if you compare our parent function to our translated function or transformed function, that they are a reflection of each other across the x-axis. And if you recall earlier, I said that we were taking all of our y values in this function and making them negative. So that's what happens when you have a reflection that's affecting your y-coordinates. You are translating across the x-axis. Now let's take a look at another example. This time we're going to use the cubic function as our parent function. So let me go ahead and get that graphed. We'll have the point 0, 0, the point 1, 1, and then the point 2, 8, which, forgive me, you'll have to use your imaginations on a little bit. And then the point negative 1, negative 1, and let's see, come on now, and the point negative 2, negative 8. So there's a rough outline of what this function will look like. Now if I apply this transformation to the function, notice that the negative is inside of the parentheses here for the x. So we're taking the opposite of x, and then we are cubing it. So that does have an impact here. So let's go ahead and start plotting some points for this function. If I plug 0 in for x, I get 0, of course. If I plug in positive 1 for x, I have to take the opposite of that. That's a negative 1, and negative 1 cubed is negative 1. If I plug 2 in for x, I have to take the opposite of that, and that's negative 2. And negative 2 cubed is negative 8. So I'm going to plot that down here. And let's see, if I plug in a negative 1 for x, that's positive 1. Positive 1 cubed is right here. Plug in a negative 2 for x, take the opposite of that, that's positive 2, and positive 2 cubed is positive 8. And so, if I connect these dots, I get this picture. Now this is actually sort of a unique situation. What I really want you to notice here is that we actually have a reflection across the y-axis. So you can kind of see that each of the branches, if you reflect them across the y-axis, will meet up with each other. But this is one unique situation where we have both shown a horizontal and a vertical reflection. So you can also see that this function in the parent function are reflections over the x-axis and the y-axis. So this just happens to be a unique situation. You won't always see that happen. But let's take a look at what the general rules are. So the general rules for the reflections, that there are two types. You can either reflect across your x-axis or across your y-axis. If you're going to reflect across your x-axis, then what you're actually doing is you're negating all of your y values. So that means the negative sign is going to come out front, in front of the function. If you're reflecting across the y-axis, then what that means is you're actually negating all of your x values. And in that case, inside your function, you're going to be impacting the x coordinates. So what we're going to do in the next video is take a look at what happens when we combine all three of these types of transformations.